Good evening. This is my first try with Ignite, so please bear with me. And this will be about the optical part of GGOS, which has been already partly described by Zuhair. So this talk will be mostly about light and about the fascination for light I've always felt in my life. When I say light, I say visible light. And so talking about wavelengths of 4,000 to 7,000 angstroms. Most of those come from our mother star, the sun, which is depicted here in the visible H-alpha line. And as you know, most of the energy coming from our nearby stars is centered in the visible part of the spectrum that you see here, of a beautiful series of triple colors ranging from the violet to red and center on the green. We have proper instruments to look at this light. We have eyes, and there must be a reason why we do not have dipoles instead of eyes in our head. So my fascination with light has to do with the fact that light has also created and allows us to enjoy art. This is Vincent van Gogh's Starry Night, very famous painting. So there are a lot of reasons for light to be enthusiastic about it. Light rules. I like light. Visible light is visible, indeed. Light is clean, does not harm, and light is cool. You don't believe me? Look at the next two slides, which are commercials from about 50 years ago. The first one is for an optical apparatus. This is a Leica M4, the queen of cameras, very sophisticated. Look how clean, how cool it is. The next one will be a microwave apparatus, which is not as cool, I think. And so this is a brilliant demonstration of the superiority of visible light with respect to microwaves. And this applies, to what we do then, to what we do for a living as optical scientists. I've also had a lifelong affair with observatories, which still continues. I love domes, I love telescopes. Through the domes, I like observing the sky. And so I was very delighted to discover that telescopes are not only light buckets, but they can send light upwards in the sky. They can send light in form of laser, very short laser pulses within this beautiful SLR, satellite laser ranging technique, which is possible because we have in the sky dedicated spacecraft. I've illustrated here just two of them, the most important in my opinion, one which are Lagos 1 and Lagos 2, which are they are very nice because they are what you can define the test particle in the gravity field of Earth, and they are cool. Look how cool the Lagos is. It's like a jewel, and it has a Carl Sagan plaque in it. So it's a very precious piece of hardware which orbits and will stay in orbit for millions of years. So it's cheap and it's beautiful. It's so beautiful, laser ranging, is that they decided many years ago to put a reflector on the moon surface. We have 5, we can range to them. And this technique is clean, is relatively cheap, and is the only technique able to pinpoint the geocenter. You can see 20 years worth of data here. Each point is a single position of the geocenter. That's a 1-year coin reported for comparison. And the only technique able to create 30 years of time series of the J2 illustrating post-glacial effects like the post-glacial rebound. The same technique or very similar technologies can be used, for instance, for important studies about general relativity. We have to mention the ILRS satellite, which has been set in orbit a few months ago, and other discoveries done and measurements done through lunar laser ranging. But most similar technology are being used by astronomers to create artificial stars in the sodium layer 90 kilometers high to correct the images from the atmospheric distortion. And actually, mostly the same technique can be used for optical telecommunication and quantum telecommunication. That is the thing we are, so you must believe me because we are working on that as well. So just to conclude my talk, and I'm getting passionate about that. My optical dream is an improved and expanded GGOS SLR LLR network to make Zuhair happy, and improved modularity and automation at the observatories to support a variety of applications. And I'm going to stop here because I'm getting too passionate about telescopes.